Right, let's do this example together. A small disk C is thrown vertically upwards at a speed of 15 meters per second from the edge of the roof of a building of height 30 meters. After 0.5 seconds, a small ball B is shot vertically upwards from the foot of the building at a speed of 40 meters per second in order to hit disk C. Ignore the effects of air resistance. Explain the term projectile. What is a projectile? Remember, we have to know the definitions. We're getting 2 marks for this. A projectile is an object which has been given an initial velocity and then it moves under the influence of gravitational force only. Or you can say an object which has been given an initial velocity and then it moves in free fall. Right, let's do P1. Calculate the time taken for the disk C to reach its maximum height. Right, let's take upwards as positive. If upwards is positive, then the initial velocity is going to be positive. So initial velocity is 15 meters per second. And then acceleration is negative. If upwards is positive, A is equal to negative 9.8 meters per square seconds. And then at the maximum height, the final velocity is what? 0 meters per second. Okay, right. There are many options, remember that. I'll just stick to one. Right. So we look at our equations of motion. Which one should we choose? We should choose Vf is equal to Vi plus A delta t, because we have the final velocity, we have the initial velocity, we have acceleration, we can easily find time. So let's substitute. 0 is equal to 15 meters per second plus negative 9.8 then delta t, meaning that we can bring 9.8 delta t this side and 15. Then we can divide by 9.8 on both sides of the equation. Delta t is equal to 1,5306122. It goes on like that. So meaning that time is equal to 1.53 seconds. If downwards is positive, initial velocity is going to be negative 15 meters per second. And then acceleration is going to be positive now. Meters per square seconds. Final velocity is still 0 meters per second. Then substitute into our formula. 0 is equal to negative 15 plus 9.8 delta t. Then we can bring 15 this side, then 9.8 delta t. Divide by 9.8 on both sides of the equation, you're getting the same answer. Then delta t is equal to 1.53 seconds. Okay. Right, let's do B2. Let's use this space here. We need to calculate the maximum height above the ground reached by disk C. Right, if we take upwards as positive, we have what? Our initial velocity, 15 meters per second. We have our time, it's 1.53 seconds. We just got our time from P1. And then A, we have negative 9.8. You have to check your equations of motion and check which one is the best to use. So we find that delta y is equal to Vi delta t plus half at squared is the best, because we have time, we have initial velocity, and then we have acceleration. We can find our displacement. Right, so let's substitute what we have. So delta y is equal to 15, then time is 1.53 plus half, acceleration is negative 9.8, and then time is 1.53, so it's 1.53 squared. Then we just put this in the calculator. Delta y is equal to 11,47959. But now we have to be careful here. We want to find the maximum height above the ground. Otherwise, this 11,48 is the maximum height of disk C from here. It means from here up to its maximum height is 11,48. But now the question said from the ground. So we have to say, therefore, will be 11,48 after rounding off here, and then plus 30. So which is 41,48 meters above the ground, right? Right, if we took downwards as positive, initial velocity is going to be negative 15 meters per second. Then time is still the same, 1,53 seconds. Acceleration is 9,8. Then we substitute into this formula. Okay, so delta y is equal to negative 15, 1,53, that is time, then plus half, 9,8, then 1,53 squared, right? And then we get delta y is equal to negative 11,47959. Check, now you're getting a negative answer to show that actually this is displacement above the starting point. We took downwards as what? As positive. Then we're getting a negative answer. So it means this is above the starting point. This is just same as 11,48 above the starting point. Then we can add 30 meters just like we did here. 30 plus 11,48, which is 41,48 meters above the ground. Let's do C. Calculate the time from the moment that disk C was thrown upwards until the time ball B hits the disk. Right, so what do we get from this information? At the meeting point, these two are going to meet, isn't it? Or these two are going to collide. At the meeting point, these two objects have the same height above what? Above the ground. They have the same height above the ground. So we need to find an equation and height of disk C being the subject. Then we have another equation and the height of ball B being the subject. And then we equate them because at the point where they meet, they have the same height. But you have to be careful about time because they don't start at the same time. Ball B is short after 0,5 seconds. We're going to discuss this during calculation. Let's start. Let YD be the height of disk C above the ground, and then YB be the height of ball B above the ground. We're going to make upwards our positive. We're not going to do the downwards, just do one. Upwards is positive. Right, for the disk, this height is going to be YD. This whole height is YD, isn't it? And then the disk starts at the top of the building here. So what is this distance? What is this distance from there up to there? It's going to be YD minus 30. Okay, that's the displacement. There are two things here. There's the height of the object from the ground, and then there's displacement of the object from its starting point. So the displacement of disk C from its starting point is YD minus 30. Okay, right. Remember, in our equations of motion, we're using the displacement, not the height. For disk C, delta y is equal to YD minus 30, and then VI, we're taking upwards as positive. Initial velocity is 15 meters per second, and then acceleration negative 9,8 meters per square seconds. That's what we have. We're looking for time. So the best equation will be delta y is equal to initial velocity times delta t plus half a delta t squared. Right, let's substitute what we have into our equation. So we said our displacement is yd minus 30. Then initial velocity is 15 delta t, then plus, oh, there's t and plus, so it must be clear here. Then plus half negative 9,8 delta t squared. Right? Let's simplify this. We can transpose our negative 30. So yd is equal to 15 delta t. Then this is negative 4,9 delta t squared plus 30. Let's make this one equation 1. So now this is the height of the disk. Let's express the height of the ball now. It's going to be what? For ball P, what we have, the height of ball P is just the same as its displacement, isn't it? It's from the ground up to the point where they are going to collide. So it's just the same. The height of ball P is the same as its displacement. So we can say delta y is equal to the height of ball P. Then initial velocity is 40, is upwards, meters per second, and then acceleration is negative 9,8 since it's upwards. Then we substitute into our formula. This is the formula we're using. Okay, so it's going to be yb is equal to initial velocity 40, then delta t. We have to be careful with time here. Right, let me give you this scenario. Let's say we are moving from point A to point B. If it takes me 10 minutes to move from point A to point B, and then you delay your departure by 2 minutes, but we arrive at the same time at point B, how many minutes have you taken? Okay, let me ask this again. Let's say it takes me 10 minutes to move from A to B, right? And then you delay your departure by 2 minutes, but we arrive at point B at the same time. How many minutes have you taken to move this distance? It means you've taken 8 minutes, isn't it? Okay, right? We say 10 minus 2, you get 8 minutes, right? It's the same thing here. So the ball was shot after 0,5 seconds, but they are reaching this point at the same time. So how many minutes did it take the ball to move from this point, from the ground, up to the meeting point? It means it took it t minus 0,5 seconds. T minus 0,5 seconds. But like I said, there are many options of doing this. Okay, we'll just stick to this method. It means for the ball, time is t minus 0,5 because they did not take the same time. Disk is t seconds, but ball is not going to be t seconds because it was delayed by 0,5 seconds. So for the ball is t minus 0,5. Delta t minus 0,5. That's our t there. Plus half, then negative 9,8. Then our t is delta t minus 0,5 seconds squared like that. Then we can distribute 40 there is equal to 40 delta t. Then 40 times 0,5, that's 20. Then this is like negative 4,9, these two. And then if you expand this, you can expand this in a normal way. Delta t minus 0,5, and then delta t minus 0,5. You can use your FOIL method here. Distribute that. You'll get delta t squared, right? And then minus delta t, then plus 0,25. Right, I know that I just square this, then 2 times delta t times 0,5, and then I square the 0,5. This will give me this. Right, let's distribute the negative 4,9. Get yb is equal to 40 delta t minus 20. Then we're distributing negative 4,9, so it's negative 4,9 delta t squared, right, plus 4,9 delta t, and then minus 1,225. Let's simplify this because we have like terms here. So yp is equal to negative 4,9 delta t squared, and then this plus this will give us plus 44,9 delta t. Negative 20 and negative 1,225 will give us negative 21,225. So this is equation 2. Now we have equation 1 and equation 2. We can equate them because say that at the point where they meet, they have the same heights. They have the same heights. So we can equate these two and say 15 delta t minus, I'm using this one, minus 4,9 delta t squared plus 30 is equal to, now I'm writing this one, negative 4,9 delta t squared plus 44,9 delta t minus 21,225, right? Now we're solving for t here. Negative 4,9 delta t, negative 4,9 delta t, they can subtract each other out, right? Then 15 delta t minus 44,9 delta t will give us negative 29,9 delta t. Then 30, if you bring it this side, is going to be negative 21,225 minus 30. So this will give us negative 51,225. Then divide by negative 29,9 on both sides. Get that your delta t is equal to 1,7132, 1,7132, which becomes t is equal to 1,71 seconds. Like I say, there are many ways we can solve this, okay, but I just did one option.